Rethinking Mathematics, Teaching Social Justice by the Numbers, Chapter 9, Living Algebra, Living Wages, 8th graders learn some real-world math lessons by Jana Dean. Jana Dean was nominated by having the most fascinating blog in 2011, and she currently teaches 6th grade math at Jefferson Middle School in Olympia, Washington. The chapter begins by Jana relaying a story in which she asks the store clerk how much she makes. It's kind of implied the store clerk works at Walmart, and she works about the minimum wage. So the goal is to use community wages to teach about linear relationships, that is, mathematical relationships in which the rate of change is steady and the graph is a straight line. She has two main goals for the chapter. The first, she wanted its students to engage their skills in math class to inform an ethical stance on social issues close to their own lives, working for a decent wage. Secondly, she wanted the students to stick with algebra, so to give students from all socioeconomic status a chance at higher math, regardless of family background. She mentions that the students start getting tracked in 8th grade, and the students pretty much align with class on whether they go up into higher math levels or lower levels, definitely related to poverty levels. So she wanted to not only use the topic of living wage to teach algebra, but hope to build a bridge between the students' lives and algebra. First, she discusses the living wage in Tumwater, Washington, which at the time was $19 an hour full-time, compared to the minimum wage at the time. She asked students questions of ethical wages and questions of poverty relating to work, and some students gave personal responses on how expensive it is to pay bills. Eventually, she incorporates using math into the larger lesson plan questions, and she begins graphing wages by giving the students hypothetical jobs such as security workers, healthcare workers, retail clerks type things. She uses different graphs such as Later, she begins inputting expenses such as work clothes, rent, travel, etc., and was able to introduce the definition for slope, y equals mx plus b, and make a cool little graph here. There you go. So the students use graphs, tables, calculators to determine the number of hours at a minimum wage job to support families of various sizes. Some made statements such as, "I'd never see my parents because they'd have to work full-time to support us," and eventually they had to defend the statement that Washington state minimum wage is high enough, but using math with analytical data and problems that they had created. So the impact is that students have an increased awareness of socioeconomic class, such as saying the students mentioned that they have other people of the same status as me. They mentioned that they wanted to start planning futures and earning good grades to stay in school so they wouldn't have to work so hard and be compensated so poorly. And Jana eventually hopes to expand the lesson to the worldwide poor, especially in contrast to the USA's top CEOs. Chapter 18, Using Data to Find Measures of School Success by Michelle Altman and Almanzia Opeo. This polls 9th grade students to define the success of a school. So within this 3-week journey, it was designed to not only help students who possess 6th grade math skills develop the use of variables to create complex, meaningful expressions, but also apply proportional reasoning to analyze real-world situations, and also use these fundamental math skills to explore equity in the education system. So this one was really interesting because it asked students who attended alternative high schools. They were racially, linguistically, ethnically, and socioeconomically diverse. The 3-week project introduced math skills and concepts that they would need for future algebra courses. B, the math itself needed to be applied to real-world applications so that there was some real value to it. And C, they wanted to measure the school success by its aggregate data, but also how it served the population in its school. And finally, they wanted the students to learn from the work that they did and also present it in a real professional way via PowerPoint. First, they asked the students, what would it mean to have a successful school? And a lot of the answers were kind of vague, like cool teachers, fun classes, those type things. So with the help of Almanzia, who is is an expert in research and equity in schools. They help define variables for these kind of grander ideas. For example, it showed them how they needed to be more concrete about the characteristics they wanted to measure, and so now they began counting things like how many students did the teacher send to the office, and using those variables they were able to define larger concepts that they had created. This type of proportional reasoning was used also for faculty, so they wanted a diverse faculty with color representation within their schools. That seemed to be important to the students. So they equated the number of diversity to the diversity in teachers to the strength of the school. And with the help of the teachers, they defined the variables clearly, such as within the school administration and the fair discipline policies. And so this was also a hot topic because recently there was a few complaints about unfairly suspending students that happened to be a certain race or gender. So this project in particular hit home with the students. They also discussed how it wasn't just an idea that was occurring at the school, but also nationally. African American students were 3 times as likely to be suspended than their counterparts, and also punished way more severely than their peers for less serious behavior. The main goal was they hoped to show the power of math and data and research to be a tool to help ask deeper questions of inequality and find answers. So they continued to quantify good or fun teachers, such as college acceptance rates, technology in the classroom, and eventually at the end they presented presentations of 5 proposed measures of understanding using direct variables, create and interpret expression, reason proportionally, and become critical thinkers about the education system and society at large. And using the equations that they created to show these 5 variables, they presented PowerPoint presentations to show what they believed would show a good school. So at the end of the semester, there was also a standard-based assessment which directly documented the improvement in students in straightforward algebraic thinking, proving that not only did they learn equity on a larger level, but the math itself also increased in ability. Finally, Chapter 11, which is Chicanos Have Math in Their Blood. This discusses how, although many cultures throughout time all started math the same way, such as counting 1, 2, 3, 4, they all wrote numbers differently. So this in particular discusses the ethnomathematics of a pre-Columbus culture that existed in Mesoamerica, which refers to the geographic area that encompasses the area from northern central Mexico all the way down to Costa Rica. The author states that the ethnomathematics of this pre-Columbus culture is frequently ignored, and teaching these mathematical traditions can contribute to infusing multicultural into education. So therefore, students will be able to see the diverse ways that different cultures perform and understand mathematical tasks. The author believes that Western orientation of the educational process has largely ignored or disregarded the achievements of conquered people, in particular the indigenous civilizations and their descendants, such in this case as Mexican people or the Mesoamerican population that existed. He goes on to speak about the Mesoamerican system, which is a vigesimal system, which is a base 20 system. It uses 3 symbols, a dot, a line, and something that looks like an eye. Here is a picture of those things. The author also goes on to discuss how Mayans had such a complex system of astronomy that they could even predict solar and lunar cycles to the day hundreds of years in advance. He discusses the history of Mesoamerica a little further, having found evidence that there was numerical inscriptions by the Olmecs in 1200 BC, which was approximately 800 years before Aristotle, Plato, and their mathematical theories and things like that. The crux of his argument is that students need to know that there are many culturally diverse ways that mathematics has been explored, and many times the Western view that's presented ignores some that have been around for millions of years, especially if they're culturally adaptable to the students and the population that is learning the math itself. And finally, that many contributions, not just mathematical or from the Mesoamerican area, they have been devalued, ignored, or destroyed as part of a rationale for subjugation and domination by a larger culture. And that's it.